Welcome to another deep dive. Today we're going to be tackling something pretty big, actually. We're talking infinity.
Sounds pretty ambitious.
It is, but it's also something that I think is deceptively simple and also like crazy complex at the same time.
Absolutely.
So we're going to try and unpack that today.
Yeah.
We're using infinity, the paradoxical convergence of simplicity and complexity. I love that title.
It's a good one.
To explore just how much infinity really affects how we understand things like math and physics and even philosophy.
It's fascinating how infinity is something that people have always been drawn to. Even ancient civilizations were already trying to understand what it meant.
Yeah, that's right. Our source material mentions ancient Greek thinkers, people like Zeno, who came up with these paradoxes.
Yeah.
I mean, they really use infinity to just like blow your mind and make you question like basic stuff like, can things even move, you know?
For sure. One of the classic examples is Zeno's paradox of the arrow. So picture an arrow flying towards a target. To reach it, the arrow has to travel half the distance first, then it has to travel half of that distance, and then half of that distance, and so on forever.
So it's like it's always closing the gap, but there's always another like half to cover. So does it ever actually hit the target?
Well, that's the paradox. Logically, we know arrows hit their targets, but the thought experiment really reveals something strange about how we think about infinite division.
Yeah, it's like you're saying, well, you can never really get anywhere because you can always just keep dividing the distance in half.
Exactly. And these paradoxes were like some of the earliest attempts to figure out how to reconcile the stuff we see in the world every day with these seemingly infinite processes.
So how did we move beyond these ancient brain twisters?
Okay.
Did anyone ever really figure out how to tame infinity?
Well, that's where Georg Cantor comes in.
Okay.
He was a mathematician, a groundbreaking mathematician in the late 19th century, and he really revolutionized how we think about infinity.
Okay, so tell me about Cantor. What did he do that was so revolutionary?
Well, he came up with this idea called cardinality.
Okay.
And cardinality lets us compare different sizes of infinity. And this was a radical idea. He was suggesting that there are different levels of infinity.
Hold on, different sizes of infinity. I always thought infinity was just, well, infinite.
I know, it's mind-blowing, but think about it this way. You can list out all the whole numbers, 1, 2, 3, and so on, forever.
Right.
But if you try to list all the decimal numbers between 0 and 1, you'll quickly realize you can't do it. There are infinitely many decimals between any two decimals.
You're saying there are more numbers between 0 and 1 than there are whole numbers, even though they're both infinite. What does that even mean? Like, for our understanding of, like, I don't know, everything.
That's the beauty of it. It really challenges how we think about infinity, and it opens up all these new mathematical landscapes that we never even considered before.
Right. I can feel my brain stretching a little bit here, but I'm into this. So tell me about these different levels of infinity. What else did Cantor discover?
Well, one of the most helpful ways to understand this is with something called Hilbert's Hotel.
Oh,
It's a thought experiment.
Hilbert's Hotel. Okay. I'm picturing like a very fancy, infinitely large lobby.
So imagine a hotel with an infinite number of rooms, and let's say every room is full. A new guest shows up.
Oh, okay. So in a normal hotel, that's a problem.
Exactly. But in Hilbert's Hotel, they just ask every guest to move to the room number that's double their current room number.
That's interesting. So the person in room 1 moves to room 2, and the person in room 2 moves to 4. But what about the new guests? Where do they go?
Well, because we're dealing with infinity, everyone gets a new room, and room number 1 opens up.
So you're saying even when something's infinitely full, you can still add to it?
Yeah, Hilbert's Hotel shows us that an infinity plus 1 is still infinity.
Wow. This Hilbert guy was playing some serious mind games.
Absolutely, but it highlights just how different infinity is from any number or any quantity that we can really wrap our heads around. It follows its own rules that don't really make sense in our everyday lives.
It really is amazing how something so simple can lead to these super profound, sometimes paradoxical insights.
Exactly, and this is just the beginning. The idea of infinity has huge implications for things like cosmology and physics, where we start asking questions about the size and the nature of the universe itself.
Okay, now we're talking. I've always been fascinated by space.
Yeah.
So how does infinity play into our understanding of the cosmos?
Well, one of the biggest questions in cosmology is the universe finite or infinite?
Whoa.
Is there an edge to space, or does it just go on forever?
So we're talking about a potentially infinite universe. That's a pretty
Yes.
big deal. So do we know?
Well, it's not quite that simple. Cosmologists are exploring a bunch of different models. Some of them suggest a finite universe, others lean towards infinity. The debate's still ongoing.
Wow. So we're still trying to figure out if space just goes on forever.
Yeah.
That's incredible. What are some of the implications of an infinite universe? How would that change our understanding of, well, everything?
Well, the idea of an infinite universe has huge implications for how we understand how it began, its structure, even how it might end one day.
Okay.
It raises all kinds of questions about the distribution of matter and the possibility of other life and the nature of time itself.
Wow. I'm going to need a minute to process all of that.
Ah.
An infinite universe.
Yeah.
It's almost too much to comprehend.
Take your time.
But before we dive deeper into the cosmic implications of infinity, I got to ask about black holes.
Sure.
Because I always hear about black holes having these singularities where things become infinitely dense.
Right.
So how does that fit into all of this?
That's a great question. It takes us into physics, where infinity plays a really crucial role. Black holes are fascinating. They're places where our current understanding of physics starts to break down.
Because everything gets crushed into this infinitely tiny point, right?
Mm.
That's what a singularity is.
Exactly. The singularity at the center of a black hole is where density and curvature theoretically become infinite.
But how can something be infinitely dense? I mean, doesn't that break the laws of physics?
Well, it certainly challenges our current models. It suggests that we might need a new theory, perhaps a quantum theory of gravity, to really grasp what's going on at these extreme scales.
So black holes are like cosmic glitches where the rules go haywire.
Yeah.
Seems like every time we run into infinity, it just pushes the limits of what we know.
Yeah, and black holes force us to confront the limits of what we know and inspire us to come up with new ideas and explore new frontiers in physics. They're like windows into the most extreme environments in the universe. Places where space and time are stretched to their absolute limits.
This is incredibly fascinating, and we haven't even touched on quantum physics yet.
Lots more to explore.
I'm ready to dive into that world where things get even weirder, but I think maybe we need to take a breath and let all this sink in first.
Yeah, infinity is a way of doing that to you. It makes you question everything.
Okay, so we're back and ready to jump into quantum physics.
So is infinity in the quantum realm as wild as it sounds?
Oh, definitely. In quantum field theories, which are basically our best shot at describing the universe at its most fundamental level, we see infinities pop up all the time.
Really?
Yeah, they often show up in calculations related to particles and how they interact with each other.
So even in this tiny world of quantum particles, we can't escape infinity. I mean, it's everywhere, from the vastness of the cosmos to the tiniest scales imaginable. It really is a recurring theme. And here's where things get interesting. Physicists have this clever trick they use. It's called renormalization.
Renormalization. Okay, that sounds like something out of Star Trek. What is that?
So think of it like this. Imagine you're making a cake, right? And you accidentally put way too much sugar in it.
Okay, I've been there.
Yeah, you could try to take the sugar out, but that'd be pretty much impossible. So instead you adjust the other ingredients, maybe add some more flour to balance out the sweetness.
Okay, so renormalization is like tweaking the recipe to deal with those extra ingredients, which in this case are the infinities. We're not really getting rid of them completely, but we're just adjusting for them.
Exactly. It's a mathematical technique that basically cleans up the equations to get rid of the infinities and get results that make physical sense.
But does it actually work? It kind of feels like cheating, Like we're just sweeping these infinities under the rug.
It might seem that way, but the results really do speak for themselves. Renormalization has been incredibly successful in quantum electrodynamics, which is the theory that describes how light and matter interact. It's led to some of the most precise predictions in all of physics. I mean, these predictions have been confirmed by experiments with unbelievable accuracy.
So we can actually use infinity, or at least work around it, to make really accurate predictions about the universe. That's amazing. But if we have to use these mathematical tricks, doesn't that suggest that maybe we're missing something fundamental?
That's a really good point, and it's something that physicists are still debating. The fact that we need renormalization hints that there might be a deeper theory out there, something like a theory of quantum gravity that could give us a more complete and maybe more elegant description of the universe, one that doesn't need these kinds of workarounds.
It's almost like we're looking at a puzzle and we figured out how to fit most of the pieces together, but there are these few odd-shaped pieces that we don't know where they go. Maybe those pieces represent, like, the limits of our current understanding.
I like that. It's a good analogy for the scientific process, you know. We're constantly refining our understanding, always pushing those boundaries, always searching for those missing pieces that could completely change how we see things.
This is so fascinating. We've gone from ancient paradoxes to this mind-blowing world of quantum physics, but I'm curious about, like, the philosophical side of infinity. Does infinity play a role in those big questions about, existence and reality?
Oh, absolutely. Philosophers have been thinking about infinity for centuries, just like mathematicians and physicists.
Oh,
One of the big things they talk about is this difference between potential and actual infinity.
okay, time for some philosophical jargon. What's the difference between potential and actual infinity?
All right, so picture yourself counting. 1, 2, 3, and so on. You can keep counting forever, right? There's no
Sure.
end to the numbers. But you never actually reach infinity itself. It's more like the potential to keep going, the idea that the process could continue indefinitely. That's potential infinity.
So it's like a journey with no destination.
Pretty much. Now, actual infinity, that's a bit harder to grasp. It's the idea of a completed infinite whole. It's not a process. It's like a thing in and of itself.
So, if potential infinity is like this never-ending journey, is actual infinity like the destination, even though you can never actually get there?
I think that's a great way to put it. It's like saying that all the points on a circle form an actual infinity. The circle is complete. It contains an infinite number of points, even though you could never count them all.
Gotcha. So potential infinity is about this, like, possibility of going on forever, while actual infinity is about this, like, complete infinite set.
You got it. And this distinction has some pretty big implications for how we think about stuff like the universe, time, even God.
Okay, so back to the universe then.
Yeah.
Is it potentially infinite or actually infinite? Or is that something we just don't know yet?
Well, that's a question that has been keeping philosophers and scientists up at night for a long time. Some people argue that the universe could be potentially infinite, always expanding, but never reaching a true end. Others think it might be a finite but unbounded space, kind of like the surface of a sphere.
Okay.
You can keep traveling on a sphere forever without hitting an edge, even though it has a finite surface area.
Right, I get that.
Huh.
But it still feels like we're, like, tiptoeing around this big question. What does it really mean for something to be truly infinite? Can our brains even grasp something that has no beginning and no end?
That's the ultimate challenge, right? Infinity really stretches the limits of how we understand things. It forces us to confront the boundaries of what we know and to admit that there might be realms of existence that are just beyond our ability to comprehend.
It's both humbling and exciting, isn't it? To realize that there are these huge mysteries out there just waiting to be discovered. I mean, we've come a long way from Zeno's paradoxes to the crazy world of quantum physics, and it feels like we're just starting to understand the true scope and importance of infinity.
Absolutely. And who knows what other amazing insights are out there? We just have to keep exploring.
Well, I think it's safe to say that our minds are officially full of infinity for today. We've gone from these ancient paradoxes to the mind-blowing worlds of math and physics. We've thought about the vastness of the universe and the intricacies of quantum mechanics. And we've even touched upon the philosophical depths of what forever could mean.
I feel like we've just scratched the surface.
I know, right? But now I'm curious to hear your personal perspective on all of this. What are some of the most mind-blowing things you've learned about infinity? What really stuck with you?
That's a great question. And to be honest, I'm still kind of wrapping my head around a lot of this stuff. It's been a pretty wild ride, exploring infinity from all these different angles.
It really has. I think one of the most mind-boggling things for me is this idea that there might be like a hierarchy of existence or a hierarchy of reality itself.
A hierarchy of reality. Okay, now you have to explain that one.
Well, we were talking about how Cantor showed that there are all these different levels of infinity in math, right? Yeah. Like there are more decimal numbers between 0 and 1 than there are whole numbers, even though both sets are infinite.
Exactly. So it makes you wonder, like, if there are all these different levels of infinity in math, does that mean that there are different levels of reality too? Are some infinities, like, more infinite than others?
Whoa, that's a really big thought. It's like those Russian nesting dolls, but with universes inside each other. Infinite universes within infinite universes.
It's a pretty awesome concept, right? And highlights how much we still don't know about the very nature of reality. It really challenges us to think beyond our everyday experiences and consider possibilities that might seem really strange at first, you know?
It's a good reminder that the universe is just full of mysteries. And the more we learn, the more we realize how much we don't know. It's like we're always peeling back layers of this infinite onion, and with every layer, we just find more and more questions.
I like that analogy. I think it really captures that feeling of constant discovery that drives science and philosophy. We're always pushing the boundaries, always trying to figure out how things really work. And concepts like infinity, I think they really challenge our ideas of what's even possible.
Well, I think it's safe to say that our brains are officially full of infinity right now. We've gone from those ancient paradoxes to the crazy world of math and physics. We've explored the vastness of the universe and the details of quantum mechanics, and even dipped our toes into like the philosophical depths of forever.
It's been quite the journey, and I really hope that this deep dive has kind of sparked some curiosity in you about the infinite.
Infinity is something that has fascinated people for like centuries, and I think it'll probably continue to do so for many more to come. It's a concept that challenges us to think bigger, to embrace the unknown and to never stop questioning like the very fabric of reality.
Couldn't have said it better myself. Keep exploring, keep asking those questions, and just keep looking up at the stars with a sense of wonder. Who knows what other incredible things are out there waiting to be discovered?
And that's a wrap on this deep dive into infinity. We'll catch you next time for another exploration into the unknown.